Okay, in today's lesson we'll discuss disaccharides, then glycosidic linkage or glycosidic bond, and condensation. Okay, so how do we define a disaccharide? Disaccharide. A disaccharide is a sugar, is a simple sugar which consists of two simple sugars joined together or two monomer units joined together by condensation or by a glycosidic linkage. जैसे डाई means two, इसका मतलब है two, और saccharides, sugar. So a disaccharide has two sugar units joined together by condensation. Okay? Examples of the disaccharides include like maltose and sucrose. There are many other examples of disaccharides, but these are the two that we have in our syllabus. So let's see condensation now. Condensation is a process of joining of two molecules together or maybe two monomer units together by elimination of a water molecule. A process of joining of two monomer units together by elimination of a water molecule. For example, if we have two molecules, like if it is an A monomer unit and we have a B monomer unit, for example, and if they join together, so they make, maybe a dimer or maybe a disaccharide. If these are the two sugar units, okay, and plus a water molecule will be formed. You got it point? So if this is a sugar unit, ये अगर sugar unit है, and this is also a sugar unit, so there are two sugar units joined together by this linkage in between them, और ये जो linkage है इनके दरमियान में, what this linkage will be known as, if it is the disaccharide, so that would be a glycosidic linkage. Okay, so this is a covalent linkage in between the two monomer units. Okay, so we can have different monomer units that may join together to make dimers. For example, if it is two sugar units, if this is one sugar unit and if this is another sugar unit, okay, so they may be joined together to make we'll discuss how. So this bonding in between them is known as, ये जो bonding इसके दरमियान में होगी इसको हम कहेंगे glycosidic linkage plus a water molecule is formed. So this is how two sugar units may be joined together to make a disaccharide. Let's see formation of a maltose. Formation of maltose, a disaccharide. Maltose is a disaccharide of 2 alpha glucose units are joined together by alpha 1,4 glycosidic linkage in a maltose molecule. You already know the structure of an alpha glucose. Okay, so if I draw an alpha glucose here, for example, if this is an alpha glucose, you know, this glucose is a hexose sugar, so it has 6 carbon in it. This is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, and this is carbon number 6. Each carbon in this case has a hydroxyl group and hydrogen with it. So carbon number 2 has hydroxyl group here and hydrogen here, whereas carbon number 3 has hydroxyl group here and hydrogen here. Carbon number 4 has hydroxyl group here and hydrogen here. Carbon number 5 has hydrogen, and carbon number 6 has a hydroxyl group and 2 hydrogen with it. What about carbon number 1 in an alpha glucose? Yes, in an alpha glucose, OH group is below the plane of the ring and H is above the plane of the ring. So this is an alpha glucose. This is an alpha glucose. Okay, we can make another alpha glucose. I'll just copy it. Okay. Just give me a minute. Okay, so this is another alpha glucose. Okay, this is another alpha glucose. Now the bonding has to be formed in between alpha 1 4, 1 of one glucose and 4 carbon of another glucose. So you can take 1 from here and 4 from here, or you can have 1 from here, or you can have 4 from here. So as this one and this one and this 4 are face to face, so I'll make bonding in between these two. However, you can make bonding in between these two as well. इन दो के दरमियान में भी आप bonding बना सकते हो. Okay? So there are actually two possibilities. If I write this is Q, this is W, this is R, and this is S. So can you tell me where alpha 1,4 glycosidic linkages can be made? Can an alpha 1,4 glycosidic linkage be made between Q and W? No. Can it be made between Q and R? No. Can it be between Q and S? Yes. Can it be between S and R? No. Can it be between S and W? Yes. Can it be between S and Q? No. Or yes? Yes. S is number 4, carbon number 4, and Q is carbon number 1. So it could be a bonding in between S and Q and R and W. Okay, so there are two possibilities here. So however, we discuss this R and W. In this case, hydroxyl group from one of this carbon, maybe from carbon number 4 or maybe from carbon number 1. So hydroxyl group from one and hydrogen from the other. So you can remove hydroxyl group from here and hydrogen from here. So this would be eliminated as a water molecule. This is eliminated as H2O. So a water molecule is eliminated out of it. And these two sugar units will be joined together by a linkage in between them, which is known as glycosidic linkage. And how that linkage is formed, I'll put these two molecules here. Okay. You got it? So hydroxyl group from one and hydrogen from another is removed here. So this hydroxyl group and this hydrogen is removed from here, and a bonding is formed in between these two. This bonding formed in between these two is known as glycosidic linkage. So this is through an oxygen bridge in between them. Okay, so this is an oxygen bridge in between carbon number 1 and carbon number 4. You got the point? So this is a glycosidic linkage, as it is in between two alpha glucose units and is in between carbon number 1 and carbon number 4. So this is known as alpha 1,4 glycosidic linkage. So this is structure of a maltose. Is it okay? Now let's see how a molecular formula that changes. So if I write molecular formula for alpha glucose 1, so this is C6H12NO6, and for another I'll write C6H12NO6. A water molecule is eliminated out of them, H2O, and a disaccharide formed will have one water molecule less in it. So this will have C12H. Should it be 24 or 22? It should be 22. And O, 12 or 11? Yes, this is O11. So this is formula for a disaccharide. Molecular formula for a disaccharide. This disaccharide in particular is maltose. Hope you have understood it. Is that right so far? Now let's see structure of another disaccharide, which is sucrose, or let's see formation of sucrose. Sucrose is a disaccharide of glucose, यानी alpha glucose and beta fructose joined by glycosidic linkage. Go there. So I'll make an alpha glucose first and then the beta fructose. So alpha glucose will be, as I have already drawn in the case above. So this is an alpha glucose. We have this alpha glucose. Okay. So this is a hexagonal sugar. Fructose is also a hexose sugar, but that's a pentagonal sugar. Okay. How that pentagonal sugar would look like? This has an oxygen here, it has carbon here, carbon here, carbon here, and carbon here. Okay, so I can write C here, and an H here, and an OH here. Okay, so this OH group is here. If I number these carbon, so these would be, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, and this is carbon number 6. So in this case as well, these carbon have hydroxyl groups and hydrogen with them. So carbon number 1 has, we can write CH2OH. This is the same way, the correct way of writing 2 hydrogen and a hydroxyl group with it. Or rather than this, you can also write, an OH here and an H and an H here. So that doesn't matter. You can write a functional group with this carbon number 1 both the ways. So I am writing this in a simpler way, which is CH2OH. Okay, or you can also write COH H2O. Okay, this is also a correct way of writing it, CH2OH. So I'll write here CH2OH. This 1 and 6 actually represents carbon number 1 and carbon number 6. So we don't need to write that here. Carbon number 3 has hydroxyl group here inside and hydrogen on outside. This has OH group here and an H here. So this is a beta fructose. Now in an alpha glucose and a beta glucose, the bonding has to be made in between carbon number 1 of alpha glucose and carbon number 2 of beta fructose, यानी इन दो के दरम्यान में this carbon number 1 and this carbon number 2. How you can bring them face to face with each other? You will have to flip them. Okay, so let me write that again. Okay, so this is an alpha glucose, and I'll copy this fructose as well. I'll redraw it. So we can flip this, this beta fructose can be flipped to bring this carbon number 2 face to face with carbon number 1 and hydroxyl group in carbon number 2 in the same plane as it is on carbon number 1. And to do that, I can flip this molecule, bringing this oxygen below. This is now carbon number 2, this is carbon number 5, this is carbon number 3, and this is carbon number 4. So if I number these carbons, so this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, and carbon number 2 will have, this is carbon number 1, and this is carbon number 6. So this is how 6 carbon will be present in this fructose molecule. The other functional groups on carbon number 2, it has an OH group here, and this will have CH2OH here, this is CH2OH here, this is an H here, this is an OH group here, an H here, an OH group here, and an H here. Do you see what I have done in this case? Beta fructose has been flipped twice so that the carbon number 2 faces carbon number 1 and hydroxyl group on carbon number 2 and carbon number 1 are in the same plane. You got it? Now what you have to do is remove hydroxyl group from one and hydrogen from the other. Okay? And I'll redraw that, and let me now just copy it. I'll have to copy it now. I don't know why it behaves like, if there is some function, that function, should be done every time the same way. कितनी देर में तो नया ड्रॉ हो जाता है, जितनी देर में ये कॉपी करने में लगता है। Okay, I'll redraw that. Okay, so if I draw that alpha glucose here, you know, this has carbon number 1 here, it has carbon number 5 here, this is carbon number 4, and this is carbon number 2, and this is carbon number 3. Okay, so this is an OH group here, an H here, an OH group here, H here, hydrogen here, an OH group here, and hydrogen here. Carbon number 1 has an OH group here, and carbon 1 has hydrogen here. Okay, and the other beta fructose, it has, you know, this is carbon number 2 here, this is carbon number 5 here, this is carbon number 3, and this is carbon number 4. So this will have, you know, CH2OH, and this will have CH2OH, and this is an hydrogen here. So this is carbon number 1, this is carbon number 2, this is carbon number 3, this is 4, this is 5, and this is 6. So carbon number 3 has an OH group here, hydrogen here, OH group here, and hydrogen here. Now this hydroxyl group has to be eliminated from one and hydrogen from the other. That doesn't matter which of the hydroxyl group you remove and which of the hydrogen you remove from both of these functional groups. Okay, so इसमें से आप चाहे ये remove कर लें और ये hydrogen remove कर लें, और इनके दरम्यान में आप ये जो bonding होगी, this would be, you know, you will have this linkage in between the two. This is glycosidic linkage. Okay. The name or IUPAC name of this glycosidic linkage is not in our syllabus. However, it would be alpha gluco 1 and beta fructo 2 glycosidic linkage. I'll write that: alpha gluco 1 and beta fructo 2 glycosidic linkage. It is just to remember the bonding is in between carbon number 1 and carbon number 2. Otherwise, we do not have this in our syllabus. So this is all about the disaccharides. Hope you have understood it.